Okay, short video lesson on square or quadratic equations, such as the one shown here. So a square or quadratic equation is one where it will have the highest power of x will be x to the power of 2, x squared. It may have an x term in it, it may have a simple number in it as well. And the only unknown will be x. It'll be an equation, the only unknown will be x, or it could be some other variable, some other letter, but it'll just be one unknown in it. So we've got a quadratic equation, x squared plus 6x plus 5 equals 0. The square equation shows us how x is related to numbers we know. Solving a square equation is finding the values of x that make it true. So notice this time it says the values of x that make it true. When we're solving a square equation, expect to find two values of x that make it true. So we expect to find two solutions. However, there might only be one solution or there might be none. So this is a very different situation to solving linear equations. For example, taking this square or quadratic equation as an example. In the video lesson about square or quadratic relationships and graphs, it'd be a good idea to look at that, to re-look at that video lesson to understand this. So from that video lesson on square and quadratic relationships and graphs, we plotted the graph of x squared, how this expression changed in value. So x squared plus 6x plus 9, the graph of the relationship is this graph here. So it goes down, it bottoms out here at 0 and goes up to 25 and up to 25 here. Now, x squared plus 6x plus 5 is would be a graph which would be below this one. You need to re-watch the video. X squared plus 6x plus 5 is 4 units below this one. So it bottoms out 4 units below this point here. So x squared plus 6x plus 5, this expression, it changes in value, but there are two occasions when the value of x squared plus 6x plus 5 is equal to 0, and there they are. So there are two times when x squared plus 6x plus 5 is equal to 0, there and there. And the values of x that make the expression 0, the values of x are -5 and -1. So when x is -5, the expression is worth 0. When x is -1, the expression is worth 0. So we can use this table of numbers here, or this graph, if the graph were drawn, we could use, it's easier to see from the table probably, when this expression, x squared plus 6x plus 5 is equal to 0 there, and there, when x is -5 and -1. So, from the table and or the graph, either x is -5 or x is -1. We have two solutions, two values of x that make that expression equal to 0. Now we're going to solve the same equation but using algebra, not relying on doing a table of values or plotting a graph. So, using algebra, we're going to rewrite the expression on the left, this expression here, as this. So what I've done here is to factorize this expression. Factorize means find the factors, and the factors are the things you multiply to make something. So this has been factorized, and what that means is I found the factors, the things that multiply together to make that. You may need to revisit the video lesson on expressions, but factorizing is an important skill when you're working with expressions. To check this, if you were to use a grid to multiply this out, you've got a bit like a grid for multiplication. So x times x would give you the x squared. You get 1 times x and 5 lots of x. You'd have 6 lots of x in total. And in the bottom right corner of your grid, you'd have 1 times 5 is 5. So remember, when you multiply a 2-part bracket by a 2-part bracket, there will be 4 components to your result. X times x gives you the x squared. In one part of the grid, you'll have 1 times x is x. Another part of the grid, you'll have 5 times x is 5x. And another part of the grid, you'll have 1 times 5 is 5. And the 1x and the 5x together make the 6x. Now, why would we want to do this? Why would we want to go to the trouble of factorizing this expression? What we're doing here is using a trick, if you like. We're going to pinch an idea from another part of maths and use it here. If we know that a times b equals 0, so two unknown numbers here, if a times b equals 0, then what must be true is that either a must be 0 or b must be 0. We're going to use that idea. So in the context of this question, this is like our a, and this is kind of like our b. So if something times something equals 0, then either that bit must be worth 0 or that bit must be worth 0. So either x plus 1 is 0 or x plus 5 is 0. So what happened was we started with a square or quadratic equation, and we've now ended up with two linear equations to solve. So we've transformed it from one square or quadratic equation to two linear ones. So we need to solve each of these mini linear equations. So I'm going to use the cover-up idea. So what number, if you add 1 to it, gives you a result of 0? There's only one number value that can be under my finger there, and that must be -1. So here we'd write x is -1. And as down here, what number, if you add 5 to it, gives 0? There's only one number that can be under my finger to make that true, and it's -5. So the two solutions are x equals -1, which will make that true, and x equals -5, which makes that true. So we have two solutions, the same two solutions as before, x equals -1, so either x equals -1 or x equals -5. We have two solutions. Another example now. So x squared plus 6x plus 9 equals 0. Here's another square or quadratic equation to solve. And let's look back at the table of values just to see how this expression changes. What happens is this expression is equal to 0 at one point, but only one point. The graph here shows how the expression fluctuates in value, and it does reach 0, but only at one point. So there's only one value of x that makes the expression worth 0. Just the value does dip as low as 0, but only just at that point. So there's only one value of x to make the expression worth 0, and that's -3. So from the table or the graph, there's just one value of x, that makes the expression worth 0, and that's -3. There is only one solution to this square equation. Right. If we can tackle this as well using algebra, we can factorize this expression. And the way to factorize it, it's like a puzzle. You probably need a grid to help you figure this out. But if we just verify this, so x times x will give you x squared. You get 3x in one part of the grid, 3x in another part of the grid. That gives you 6x in total, and 3 times 3 is 9. So we can factorize this expression to give, and rewrite it to give this looking different, but it amounts to the same thing. This equation and this equation are the same. They've just been rewritten using the factorizing idea. What this then means is using the idea that if a times b equals 0, this means that either this is nothing or this is nothing. So either this is worth 0 or this is worth 0. So either x plus 3 is 0 or x plus 3 is 0. So I'm repeating yourself, aren't you? So we now have two mini equations to solve, and if I cover up this, the value of x must be -3, and here as well, the only value of x that will make that true, a true statement, is if x is -3. So that leads us to two solutions, x is -3 and -3. So it seems to suggest that there are two identical solutions, but this is not the reality. The table and the graph show us that there's only one solution. So if this happens when you factorize, it looks like you have two solutions, but you don't. It's just one solution. That was clear from looking at the values here. X squared plus 6x plus 9 is equal to 0, but only at one particular value, only at one particular place on the curve, which is just there. Right, let's go back through these. One final square or quadratic equation to solve: x squared plus 6x plus 13 equals 0. If we look at the table of values, what we find here is that x squared plus 6x plus 13 starts high, goes down, and comes back up again. The snag is that the lowest point on the curve, the lowest value expression ever achieves, the lowest value ever achieves is 4. This expression, x squared plus 6x plus 13, never, ever, ever gets as low as 0. So the equation x squared plus 6x plus 13 equals 0, there's no value of x. There's no value of x that can make the expression that low. So that expression can never equal 0, and this equation has got no solutions. There is no value of x that can make that true. So what's unusual here is a square or quadratic equation can have two solutions, and I would recommend that you expect to get two solutions, but it can have just one solution and it can have no solutions at all. That will do. Thank you.